Hi, today we'll be discussing Chapter 3 of the Jay Leibowitz book, Frontiers of Big Data Business Analytics, Patterns and Cases in Online Marketing. Our group is composed of Chern He, Clayton Burrows, and myself, Joshua Wilson. The chapter really talks about how computer technology is changing our lives, and it's doing so at an ever increasing rate. For example, he gives the fact that through the dawn of civilization through 2003, the amount of information that was collected can now, by 2010, be collected in just 2 days. So information is being collected at a ridiculous speed, and there's more ways than ever to collect data from processors and microprocessors on your everyday equipment and your phones, and even common things are being automated and be able to track data and create data. So there's new data sources. We also have better ways to analyze that data. Computers, statistical tools, and they're increasing in their capability, and they're becoming very cheap. So ultimately our computing power is going up dramatically. We can store it easier, storage is cheaper, wider bandwidths, lower cost. The problem, of course, is that data is just data. The more it is collected, the more it really needs to be analyzed. Without analysis, that data is not actionable. So we end up with a bottleneck with all this data at the point of having data savvy people. And making that data really actionable is the big problem in this chapter, because without people and ways to process this data, we can't get through the end of the funnel and actually grab those business advantages. There's really a few things that computers are especially good at. For example, they have perfect memory, whether it be across time and very intricacies. They can take years, decades, hundreds of years of data, if you get all that, and be able to track it absolutely perfectly instead of having to be exposed to human memory. Also, those intricacies of data, not only can it know that you ate at Chipotle on December 5th, but it can know that you had guacamole that day instead of most days you didn't. So the intricacies give us many ways to track. Also, it has an extremely high ability to search. You can really find the needle in the haystack in a tremendous amount of data that could, in reality, take a human analyst years to find if they had to do it without computing power. Computers are able to sort through calculate trade-offs among a huge number of factors that really humans have psychological biases against being able to do that, and have the inability to really focus on the ones that matter. They have an uncanny ability to predict behavior over a large number of people. That's really the basis of many industries, such as marketing and insurance now. They can find repeatable patterns and do so quite easily. And honestly, many insights and predictions, they can figure out what we can and cannot get from the data. Is the data really telling us what we hope to find? And do so with an extreme level of accuracy. Also, it can notice unintentional evidence. For example, someone may tell you the reasons that they make decisions, but actually not really understand they're being influenced by other decisions. For example, if you ask someone why they bought a certain brand of cereal, they would tell you the reasons that they know of, but they may not understand that in their particular town, in their particular zip code, people are more apt to eat that cereal. So they can notice unintentional evidence. They can also scale personalization solutions. And ultimately what we see is with more data is a huge advantage, because with more data we can build better models. And with those better models, of course, the goal is to have better optimization, get better results. But ultimately computers can't do anything. They're limited by the analyst's ability. They can follow bad instructions. They can gather and consider the wrong data, because and essentially they don't have intuition. So the analyst can essentially lead them astray. One bad decision and all of the computer will follow that. And they can't really generally analyze their own cleanliness. So it all comes down to the computer can't really be better than the driver. Ultimately, computers are going to fail when it comes to predicting whether a small sample will have a behavior that's predicted for a population. So, for example, if you have a male who's 40 years old, 70K, single, 620 FICO score, that computer can tell you with great accuracy that about 85% of the time, that guy will be always on time for his payments versus 15% of the time he's either going to go into default or payment plan. So it's very precise on that. But where he fails, the computer fails, is when you have one guy in front of you. What's his chances? With this is all the information we have. What's his chances of being in the 85 or the 15%? And ultimately, that's where computers get confused. That's where they fail in having a human interaction to really kind of interview and see what else is there, have that intuition. It matters a lot.
Hello, my name is Chern, and I'll be continuing from traditional business intelligence and big data. Firstly, what is traditional business intelligence? Well, traditional business intelligence is shaped like a pyramid as illustrated in the PowerPoint here. And it starts from standard reports and it goes all the way up to knowledge discovery as an organization matures. As it scales the pyramid upwards, data volumes will increase and so will its complexity. And most companies are actually stuck at the multi-dimensional stage, which is approximately around the middle of the pyramid. This could be caused by various reasons, but the most common ones are they may have just built a data collection infrastructure, or they may have lack of analytic talent. So next, we have data structure decisions. We have to know that it has to be made before loading raw data into a database. So, for example, in an SQL server environment, all the tables has to be properly normalized before data is actually populated into it, which leads to our next point, where implemented designs are difficult to change. So in an SQL server environment, the tables, the database structure will be hard to change once everything is populated in. This is why it is important to do things right the first time. And organizations strive to achieve the knowledge discovery stage because it will give them a competitive advantage in their industry. With that, it is important to satisfy two factors we have here, which is to conduct a detailed analysis before building standard reports, and decision-making process should include people who know how to analyze data. Next, we will cover understand that models have to be designed by people. So people generally would define questions, which is the role of an analyst, decide the model to build, and the most important of all, selecting variables. This will help the organization avoid solving the wrong problem, which is one of the ultimate goal in data analysis. And we know that computers have no way of knowing whether there is a problem in the model. It only processes things and it has no goals to achieve. And goals are usually specific to each organization. So the analyst will define question, decide model to build, and select variables which are relevant to the company's goals and relevant to solving the correct problem encountered by the organization. So from here onwards, my teammate will continue about models have to be designed by people.
Hi, my name is Clayton Burrows, and I'm going to be talking to you about data and whether or not it's perfect and how it can fit into the modeling process. Data is not perfect. Data is always a close or not close approximation of what we're trying to represent and measure. There are measurement errors, there are recording errors, there are typographic errors, there are clerical errors. But some data sets are still very good. They closely approximate what we're looking at. And of course, this implies others are not. So there's a QC process that has to go in, and we can't just depend on the computer to do this. While it is possible to automate some of the error measurement, it still requires knowledge from the analyst and instructions from the analyst to do these things. But when the analyst is giving the computer the right instructions, we can QC the data, we can build models, and it's a very nice match. We're still doing the thinking, but the task is being executed by the machine. So we're going to look real quick at a example of a possible analytics event that is involving Hadoop. And so we're going to look at the unstructured data, where it's stored, where the analyst may be interacting with it, structuring the data using machine learning, and then insights for data-driven decision making. So the first little segment of this chart, we're collecting some unstructured data. As my colleague mentioned earlier, we're producing tremendous amounts of data. And if it's copious amounts and it's unstructured, we might use something like a Hadoop distributed file system, which will be running on the cloud, big servers, databases, and we'll probably be using a cluster to interact with those as well. Now, of course, there's an entire amount we could go into on the data engineering behind this, but let's focus on the analytics event. Black box engineering has occurred. Now we move on to the executives and the analysts. There needs to be a discussion and some problem framing. We can't just jump in and start mining and start doing things. So you have to frame the problem with the stakeholders to figure out what they're trying to solve, and then consider, okay, what's the best way to go about solving this? So get in the ballpark, then do the data mining. Now you've got some structured data. And different mining processes will create different structures. So like I said, hopefully you matched the right process for the problem you're trying to solve and the data you had. Now we can apply some machine learning, which is not completely outsourced. We're feeding the data in. We might be doing regression, some sort of Bayesian type analysis, measuring errors, and validating our model. But when we go through that entire process, we'll have something that can give insight, make predictions perhaps, make measurements, find problems we didn't know we had. And that will help the stakeholders make data-driven decisions. Example of this is Yahoo. So not quite the exact flow chart I just showed, but something similar. They had over 200 million users and had no idea what to do with the data. But they were able to do some optimizing and clustering analysis and got that down to about 100 segments. So basically they have about 100 type of users. So they were able to figure out, hey, this person is using this type of product. For example, music, used mostly by young females, turns out. News and finance, mostly male. The email, by far the largest application. In fact, part of the reason people went to that Yahoo webpage was just to get the mail. They didn't realize they could go directly to mail. So this gave them insight on how their products are being used, and they were able to use this to make decisions in how they marketed their products and tried to grow their company. In conclusion, computing power is powerful. Business advantage with analytics is still huge. Lots of businesses are pretty low on this pyramid over here. And it's because it's difficult. Computers don't do this. We instruct computers to do things. But it's really still the data scientists and the analysts who are initiating the analytic events and are deciding when, okay, we have a model, let's go out and apply it. This is still being done by humans. Be sure to match the model to the problem. Make sure you're solving the right problem. And then, as always, make data-driven decisions. Don't let shorthand heuristics and biases dominate your life. So thank you very much. We enjoyed making this video and this PowerPoint. I hope you were able to glean a lot from it and that you enjoyed it too.